Hi, welcome back. So we are at section 2, concept of object. Let's go ahead and review the outlines we shall be covering in this section. Essentially, we're going to be talking about how to create a Python class after we have learned that class represent the blueprint to instantiate objects after the analysis and design step. And then we're going to be looking at modeling and packaging using Python as the blueprint for that. Because once you start to actually enlarge with your project, you can't just work on a particular script as the single file. And then we're going to be moving to talk about how to organize those models and their content. In particular, we're going to discuss the data access using one of the most important features in object-oriented, that is encapsulation. Following that, we're going to be talking about how to deal with some third-party libraries by importing them and interacting with them. Of course, finally, we're going to close down this section with a real case study to put down all the information that we learn in this particular section. So let's go ahead and start with the first outline of the section, that is how to create Python classes. Number of the to-do list in this particular outline. Number one, how to create class in Python. So I'm heading back to my Visual Studio Code interface that we have set up and installed earlier on. The important thing is to realize that I have created this particular project folder that represent everything my project will be within that particular folder. And of course, this is the virtual environment that we spoke about last time. Now, what is going to happen from now onwards, for each section, I'm going to be creating a dedicated folder, which I'm going to later on share in the GitHub repo for this particular project. So in this case, let's start first of all by creating this folder. Let's call it section 2. Essentially, of course, we need a script. So here I am going to create a new file and let's call it main.py. Now .py represent that this script is going to be reading with Python. So the first thing we want to do is to ask the question how to create a class in Python, because we know what does class mean. Now to create a Python class, it goes as simple as using a keyword that is called class. Now the second thing, of course, after I use class as the keyword, I'm going to indicate what kind of name of that class would be. In this case, let's just, for illustration purpose, say my first class. Now for the naming convention, not in Python, in every industry related to coding, it turns out to be named with a camel case that indicate this is going to be a class. Now, the next thing is to do after I use class as keyword, my class, I'm going to use colon, and that's it. Now I am inside the intent, as you can see here, after the colon, to start writing whatever within that class. Now, the only thing I'm going to do for now, just will use this keyword called pass. And pass, it tells interpreter you do nothing. But we have a class, we call it my first class, and that's it. Now, that's it. Actually, this is the way we create class in Python. It goes as simple as you can see in here. Now, this is a class, and we need to start to instantiate objects out of that class. So I can create object 1 and 2 and 3, and all of them are instantiating from this blueprint, a class, which for now does nothing at all. But anyway, how to start actually interacting with this class? There's so many ways, but I'm going to show you abstract one, then we can use much more intuitive kind of a standard. Of course, the first thing I'm going to hit back to this button here to toggle the terminal. And if you remember here, the terminal, where we are right now. So I open the terminal in PowerShell. You might have some other terminals. It doesn't really matter. Don't forget, we are working on a virtual environment concept. I didn't want to work on the actual base environment of Python, as we said before. So we created that virtual environment in a previous video. Now, what I need to do is I need to activate this before I start actually working. Just hit ls here. It shows you where I am on that particular directory. So the virtual environment is in here. Activation that we talked about before. Now my environment is active. Now I am actually inside this virtual environment. Now the next thing to do, of course, is to execute the main.py to start now in instantiate objects. And so I could just call Python, which is the engine interpreter, to run and interpret this particular file. However, before that, I would like to show you something. I'm going to use this particular argument called I, and then I'm going to call on main.py. Now, what is this I actually argument tell? This I argument tell Python to run the code, which is we just wrote here inside the main.py, and then drop to the interactive interpreter. Let me show you what does that mean. So if I just click here, you can see it run actually the main.py, and now it dropped me into this active interpreter. Now, this is Python shell. I can start now using the command shell to do that. Now, this is not actually an ideal way, but I just wanted to show you a few options. We're gonna, of course, use a different, easier way to interact with the script that we write. But anyway, so what I could start with now creating objects. Let's say I'm creating the first object, let's call it A, and then I just say, what is this A gonna have? Well, I would say this is gonna be my first class object. So it instantiates from my first class, which is the interpreter now is aware of existing, and A will be the first object I instantiate. I can create more objects like B, for example. Now I have two objects. How can you find out? So if I could use this function print, what is this A? It is an object and it occupied this particular place inside the memory. And then if I print again for the second object that I created, I would see once again, this is an object occupied in the memory, and this is the actual address of that object. So we have seen now how to create a class and how to instantiate objects out of that. This is one way, of course, to start to interact with the class that you created, but it's not an ideal way to use this command. Some people might be intimidated with that. So what I'm going to do, I'm going to create actually alternative way of doing so. For now, what we're going to do, we're going to just pass out of the class. You can see the indentation. So everything within that indentation, it will be considered within the class. But once I am out of that indentation, whatever I write here has nothing to do with the class actually existent. So what I'm going to do just to differentiate that, I'm going to just create this line here. And of course, now it shows me an error because he read this as if it is a code. That's why I'm going to put this one to be as if it is just a comment. So the interpreter will not read this one as a part of code. So I'm going to say here, run command. Again, I'm going to do the same exact thing what I did just now. So I'm going to go back here. Instead of using this I'm going to be deleting this argument. I don't need it anymore. So it will not drop me to the interpreter. I'll just run directly the script. So when I run the script, you could see everything happens as we expected. This is the way I'm going to be working from now onward. So you can see these are the two new addresses for these two objects I created. Now we're going to be talking about how to add attributes. So I am back here to Visual Studio, and let's now do the following. Let's create a class. Let's call it point. This is my class now. I'm going to now instantiate an object. Let's call it point1. I'm going to create one more point. Now, question is that, what do we mean with behavior? It means what kind of characteristics each point will have. Now, I could start with point one. And now if I use dot, which is the simplest way to reach to any characteristic that is actually associated with this particular object I have just created. Now, you see those as a list while I created. We're going to be talking about some of them. These are built in with each object by default. You will see them. But anyway, it's not my interest here. I'm interested to create completely a new behavior. Let's call it X. Put it to 5. Let's set one more coordinate. Let's call it, for example, 4. Now, object 1 have 2 coordinates. And then I could do the same exact thing with the second point. Now, if I would have to go and print, you might tell me, well, but these behaviors that we were talking about, we did not create them within the class. They are instantiated on each object. This is one way of doing so. As expected, we have in the first coordinate of the first point to have X and Y, and the second one X and Y, because we already instantiated that. Now, interestingly enough to know that if I would have delete this, just to show you that X and Y are actually as a behavior created only for this object. They are not by default for the whole class. Go and try to attempt to call on the behavior for the second object, I will be running in an error. He printed the first. It's okay because we know that there are 5 and 4 we set as a characteristic. But when he went to the second line to print, he threw this track an error. And what is the error? It's an attribute error. Attribute, remember characteristic. He say point object, which is this object, the second, has no attribute called X. And if he pass X, he will not have Y too. Now, the next thing we want to talk about is how to add behaviors, because we know now object is just the encapsulation of number of attributes, characteristic, and number of behaviors. So behaviors are the actions that the object you expect it to actually be doing. So the first thing I'm going to do, I'm going to create a function. So I'm using this keyword called define, something called reset. Now this is a method, right? This is the behavior. Since this method is a behavior within a class, we're going to use this keyword called self. I'm going to talk about it in details and why this self is very important to be understood. I'm going to now give this X and I call it 0 and self.y. I'm going to just call it 0. So what I did here, nothing special. I just created these two characteristics, and I'm saying, well, whenever you call this method, you're going to go to these two characteristics, or to coordinate X and Y, just set them to 0. So once again, I'm going to get back to my run terminal. Now I'm out of a class. I'm going to instantiate this object called P. I'm going to, of course, instantiate from point, right? As we know that. But the only thing is different now. I'm going to call P. We see the reset. Go ahead and print coordinate of 0, 0. Now this 0 and 0 were not set within, the object itself did not set X and Y. It just called a method that does the job. All right. Let's now talk about the concepts of self keyword. So we have seen when we created this point class, and reset, actually it requests a particular, looks like an argument here. In fact, it is not an argument. It tells the self will represent the actual object that you just instantiated. So self here represent as if I am passing P1 to it, as I'm passing P2 to it. So self here could be represented with any other word, but the most popular concept is called self. Actually, to make things much more clear to you, maybe I'm just gonna delete this P2 for now. If I would have to run this particular part of the code, as expected, right? Nothing happens special, but here is the point. When I instantiate this goal on the reset method here, the reset method will take the object that's been created, so he knows now he's talking about P1. Now there is alternative way called the class itself reset method. Now this is within the scope of the class. Open the argument here. It expects you to pass an object of type point P1 here. So this is alternative way of actually doing exactly this. This line and this line are actually identical. Now let's talk about more arguments giving the actual method that we construct within a class. So I'm going to here use a keyword before we even start discussion further called import. All right, import, it will import an external libraries that we're going to be taking time to talk about in future. I will call this a built-in library called math. So what is this math? It's just another script, somebody else wrote it with a lot of built-in attributes and of course behaviors or methods. I'm going to create here move. Of course, we don't want to forget always the self with two more arguments, X and Y. And what move does exactly, it's moving the actual position of X to be equal to the point you pass to me, actual position of Y to the position you pass to me. Reset that we done earlier on, it's going to do something more interesting. It will call move and will actually just pass to it 0 and 0. So reset is to put the point back to the origin of 0s and 0. Last but not least, maybe we can calculate a distance between 2 points. I will call this function calc dist. So once again, I'm going to call self, and here I'm going to just call an object, just call it other point. I'm going to use math, the one I've just imported here, and I will import a particular function called the square root of. So I'm going to follow now the actual Pythagorean theorem. Let's create one point. Let's call it P1, all right? Another point, I'm calling reset on it. Reset will actually call move and pass 0 and 0. So P1 now coordinate will be 0 and 0. Great. Now the second thing I want to do, I'm going to call P2, but this time I'm going to actually move. So I'm calling move directly now. I have to pass a new position for that. Let's pass, for example, 5 and 0. Let's go ahead and print. I will take the point 2 dot count the distance. I am opening now from point 1. We should get 5, and 5 is the actual square root of 25 if we do the calculation correctly. Now talking about the initialization of the object. For example, let's say I'm creating a point here called point 1, right? P1 dot x is equal to 5. It will work, right? And then I'm gonna print here the P1 dot x and P1 dot y. Let's run that and see what is the result would look like. It's gonna throw an error. This object does not have such an attribute called y. And that's why this kind of issues is related to the initialization of the object stage. And this is where the concept of two important things that you must be familiar with. Now, in some other languages, they call it the constructor. Constructor says, whenever you have a new object is initialized, I want you to apply this characteristic or method on it by default. Now, Python has a different idea of that. It uses actually constructor and it uses something else called the initializer. And both are different in Python. Most of the time you will be working with initializer. I think very, very rarely you will be working with what's so-called constructor. Let me show you what does that mean exactly. Let's start first of all with the initializer idea. Well, it is attached with the built-in method called underscore init, which is basically tell the interpreter whenever you start the initialization of any object, make sure that whatever inside init must be executed. Now here I can take advantage of that by doing the sum. I just underscore, you could see beside this argument, take more x and take more y. And here what you're going to do, just self.move. All right, and pass x and y. P1 here asking me, and I must actually provide x and y as the initialization of this object. Now I am forcing every new point to have a specific position. It doesn't have to, you can just initialize a point without giving me the exact position of that point. So here if I would have to put 3 and 2 and then I could go and print, I will be okay, not like as previous what happened to me. Now interestingly also, I could actually on the fly change and run once again. Here we go. It actually changed the value even after initialization of the object. But the point that once this object is initialized, this point will be by default out there. This is the main concept of actually initialization. Okay, I want to actually create an object, but I don't want every time to initialize specific point. So I want just to do like before here, but I want a default. In this case, we use the equal. So if I would come to x and just set it to 0 here, and come to y and set it 0 here, and just do that one more time, it will work. Why? Because the default value will be 0 always. Now, the second important concept, as I said before, is using what's so-called a construct. Now, construct is related to another a kind of a method. We call it inu. So whenever you see this in Python, which is rarely you might work on, it actually also indicate what's so-called constructor in other languages. Now, to be honest, as I said before, inu is really, really rarely used, but I will tell you when to use it. It's actually rarely overridden, as you can see here, but it's useful in specific scenario. For example, if you are implementing a singleton pattern, which ensure only one instance actually should be created out of that class. In this case, you want to make sure no other instances are created. Also, in returning a cache object, if you are creating something related to memory optimization thing, so it reusing existing object instead of creating a new one. So the same object will be created again and again. that will be an issue. That's why you want to make sure it's only one time created, and then you can use it again and again. So no other object will be created. Also, in this case, called immutable object creation, which use in a class like a string and tuple. Since they are actually immutable, you can create as many objects of them. Also, in subclassing immutable types when existing like built-in immutable types like integer or float or string, etc. As I said before, I personally have never used actually the new constructor in Python. Maybe in other language, of course I did. But anyway, it's your choice, and no harm to be aware of that. Now, the last thing to talk about is called the docstring in Python. This is the way where you want to actually explain yourself. Imagine I am writing this class and I want to make it available to other people to use it. In this case, of course, when you want to use this a class, you must tell them an idea how it works, what it works. This is not exactly the documentation here, but explanation in some way or another. For example, for the class, I'm going to just say it represents a point of 2 dimension. Now, what is the docstring? It actually take this 3 double quote point. You can use also single quote point, and then you can write here an explanation about this particular function. This class has been well written, say for example, large class, and it has all these docstring explanation about how it works, what the function. I can also give some extra information about that. Now, how to utilize that and how to show you why is that really looks good. If I would have to get back to my argument called I, it will drop me to that interpreter that I spoke about before. And here I'm going to use something called help. And in help, I'm going to just call on this class for the interpreter to tell you what are the details of that class. Watch carefully what will happen. I will have this beautiful kind of a tree explaining to me exactly what are the exact functions that in that there. This is the exact idea of having to explain yourself through what's called docstring in Python. All right, so we are now ready to move to the second outline to talk about models and packages in Python. That's exactly what we're going to be doing next. I'll see you then.